Hello and welcome to Chapter 4. Now we're going to come back and visit what I alluded to in the first chapter of the fourth pattern for code. Sequential, conditional, iterations, and then store and reuse. This is the store and reuse pattern. And the basic essence of the store and reuse pattern is that we as programmers do not like repeating ourselves. So if you have like 4 lines of code and you want to do the same thing later and you put it down here and then you put it later, and what if you find something wrong with those 4 lines of code? Then you got to find all the places. And let's just say you put it 100 places in your program. You got to find all 100 places and fix the mistake. So we say, well, why don't we put that one place and give it a name and then use it in all the other places? And that's exactly what store and reuse is. It's the idea of don't repeat yourself. DRY, don't repeat yourself. So this is what we've got here, stored and reused steps. And functions are those things that we're storing and reusing. So let's take a look. So the new keyword that we've got is def, D-E-F, which stands for start the definition of a function, define function. Def is the keyword. It ends in a colon, just like lots of things that start an indented block. That starts an indented block. You get to name the thing that you're storing. I call it thing for now. And there's some optional parameters, which we'll see later inside parentheses. Right now we have no parameters in this function. And then there is an indented block. And then when you de-indent, that defines the function, right? So this thing has been de-indented, but it also, this T is de-indented. And so that is the definition of the end of the function. Now, it's key to understand that as this is parsed or looked at by Python, it actually doesn't execute. There's 2 executable statements there, print and print. But all it does is it remembers it. So it sort of like stores it into a little area, almost like a variable, right? Like a variable, x equals 2. Well, there's some x out there, and you put a 2 in it. Well, there is this thing out there, T-H-I-N-G, and there's 2 lines of code in it. So it's like a variable, except that it holds code. Okay, so a function is kind of like a variable, except that it holds code. And then most importantly, it doesn't execute these lines of code. So no output, there's no output here. Nothing comes out from that first part. Now, it has a side effect of extending Python, so there's this new thing that we can call. So we call this calling or invoking. So we've made one of these things. Now let's call the thing. So we say thing parenthesis, and that's the syntax to say go call the function. Now we've been using functions. Print is a function, right? Print, parenthesis, parenthesis, parameter. That's how print works. Well, thing is a function. Thing, parenthesis, but there just happens to be no parameter in this because this is a really simple function. So what happens is def does nothing but remembers. Thing then says, oh, let's go back and run that thing. Run those 2 lines, so out come hello and fun. And then it comes back down to here, runs this print statement, so out comes zip. And then it says, oh, run that code again. So this is the don't repeat yourself part. Run this, print, do it again, and now the program's done. So it comes back here. So one of the things about functions is that Python, when it calls a function, it kind of remembers where to come back to. It's like, oh, okay, go up here. Now I'm done. Where do I go back to? Oh, I remembered to come back to here. So then do this. Okay, here's my coming back place. Run up again, run, go back to the coming back place. So it's like it sort of pauses this code, pause here, run this, and then resume there. So it's like jump and then come back. So we've been using functions all along, things like print, input, type, float, int and float do conversions. Type tells us what kind of a thing something is. Print stuff out, and input reads stuff from the user. And then there are, later we'll talk about functions that we're going to make and then use. As we extend to Python by building functions, we can think of them as like new reserves or function names. And so the naming conventions for function names is the same as for variables, and you want to avoid things like reserved words and other things like that. So functions, some bit of reusable code. We define a function using the def keyword, and then we call or invoke. We mostly say call, but I think of invoke as a little clearer. It's like invoke this function, like do it right here, with a function name, parentheses, and then optional arguments. So here's a function that we haven't played with yet called the max function. It's also another one of Python's built-in functions. And this is an example of an argument. We're passing in a string, and we're asking max finds the largest of something. And in this case, it's going to scan through this string and find the largest letter. And it decides that W is the largest letter, Apparently lowercase letters are bigger than uppercase letters. And then it does what's called a return, and it gives us back the thing that it's like, you asked me to find this, and now I found a W. Here you go. And then that W gets assigned into VIG. So if we do a min, which is a different function, we pass it in the same hello world, looks for the smallest thing, and for some reason space is the smallest thing. So this space is what gets sent back to tiny, and there's a space right there, and away we go. So at some level, you can think of this max function as a chunk of code that's been built into Python before. We are passing in an argument, which is a string. There's some code inside here that runs, reads through the argument, it comes in, and then it reads through and looks at that stuff, reads some stuff, and then sends us back the answer, which is W, which is this is called return. It returns us something, and then that W. So you think it's working on this side of this assignment statement. The W is the residual value once the max function is executed, and then that then is assigned into big, and so big has the letter W in it. So the kinds of things that we've been playing with so far are type conversions, and so here goes Python. It's looking at what to print. It's like, oh, I got an expression here, but wait a sec, I'm going to do this. But wait, oh, I got to call a function. So there's a little float sitting out here, little code for float. We pass a 99 in, and we get back 99.0, and then that 99.0 divided by 100 gives us 0.99. So it sort of pauses its calculation, and then it goes and runs this float code, and then comes back. Now we're going to make a variable I, 42, say what kind of thing it is. It's an integer. Now what we're going to do is we're going to pass this integer into that same float code, 42 into the same float code, and now it's going to come 42.0, and that's going to replace this in the function, and that's going to be assigned into F. And so, surprise, surprise, we have 42 in F. We ask what kind of a thing it is, and then it's going to do this calculation. Remember, it's going to do the multiplication first, the division second, so it's looking at 2 times float. Oh, hold on for a second, stop for a moment. We now have to run float, which means we take this 3, we pass it into the float code. The float sends us back, in this case, 3.0, which replaces this in the function as 3.0. And then we end up with this calculation of 2 times 3.0 or 6.0, and then on and on and on, the rest of it finishes. So you think of this function calls as suspending what we're doing, just for a brief instant. We're going to suspend that and then wait, and then the function will give us something back to replace that. Okay? String conversions as well. We have been using int and float to do things like read things in because input is a function, but it always gives us back a string, and it gives us a string. We might want to use this as a number. So the string 123 is not the same as 123. That is a string, and if we do something crazy like add 1 to it, boom, we get a trace back, because we can't concatenate string and integer just because they're the wrong type. But if we take this same 23, and here's a little code called the int function, we pass sval in, which is 123 the string, and we get back 123 the integer, then that replaces this in the function, and then 123 the integer is assigned into ival. We say, hey, what kind of thing is ival? Well, it's an integer. We can add 1 to it and get 124. And this came from a previous chapter. If we happen to be calling int and we pass hello Bob in, oh, I should have used a different color. If we pass hello Bob in, this code blows up. And it says, oh, trace back. And that blew up. So even a function can blow up. And you know what? Our code blows up. So the function blows up, and away we go. So up next, we're going to stop using built-in functions and actually define and use a few functions of our own. So now we're going to build some of our own functions. We sort of saw a little bit of that syntax at the very beginning. We're going to explore using the def keyword and some of the choices that we get to make. And so the essence of this, I'll say this probably 20 times. The def statement only defines the function. There's a side effect to it, but it doesn't actually run the code. It just remembers the code, and then later we will call and invoke the function. So here's an example of some dysfunctional code that's not going to work very well. And so we come in here, we set x equals 5, and you don't have to have the def at the beginning of the program. We do a print statement, so out comes hello, and then we do a def statement, and that cruises through here, and the result is you have extended Python to have this thing called a print lyrics function, and it's got 2 bits of code in here. Now this print does a de-indent, so that sort of blocks this off, as that little bit inside the block is the function. That stuff's been copied up to there, and now it continues on, and it prints yo, and it adds 2 to x, and then prints x, and out comes a 7, and now the program is done. What happened to these lines of code? The answer is they never executed. They never executed. And that's because the def statement doesn't automatically run the code. You must invoke. We did not invoke the function. I'm not sure if that's a happy face or a sad face. It's a wry face. It's a wondering what's going on face. So we didn't invoke it, right? We didn't invoke it, and so it did not work, and we didn't do any output. Now, why we did this, I don't know why we did this. Question mark, question mark. Who knows why we did this? But what we really meant to do probably is something that more looks like the next bit. Once you define it, we got to call it. And that's the reuse part. We had the store part working, but not the reuse part. So here we go. This is a little more of a functional bit of code. Set x to 5, print out hello, out that comes. Define it. This creates no output, but the de-indent causes this block to be part of that, and that's sort of been stored. Store. Now we print out yo, and so out comes yo, and then we call print lyrics. Again, print is a function, has parentheses with parameters. This has parentheses with no parameters. We didn't put any parameters in. We'll get to that in a second. Print lyrics now says, oh, run this code. So out comes these 2 print statements. Then we add 2 to x, print it, and then out comes 7. So this is the store. This is the reuse. This is the call. This is invoke. Okay? Okay. So everything we've shown so far has no arguments, except this max did have an argument. That max is input. And then we will get something back, the w, and then the w gets stuck into big. So arguments are input. So if we want to define arguments in our own functions that we're making, we just put them in the parenthesis. Now, it's like a variable. We're choosing a variable name. But this variable sort of doesn't exist. This lang variable is best thought of as an alias. It's an alias for whatever the first parameter is going to be when that particular function invocation happens. Okay, so we're going to invoke this function 3 times. We're going to put in parentheses 3 different things. This is a way to have code that's almost the same, but a little bit different. By pushing in different parameters, then the code does something different. And so this really is just a placeholder to say whatever the first parameter was. If that first parameter is ES, then print this. If the first parameter is FR, print that. Otherwise, print that. So as our program runs, this accomplishes nothing, doesn't run any code, but it creates this thing called greet out there. And we've indicated to Python we expect a parameter. We expect that when this is invoked or called, we want one parameter. So then we call greet. And again, Python remembers to come back to here, and then it fires up to here and starts this line of code. And en, lang, is an alias for en. So it's like lang is not es, lang is not fr, so this code runs. Out comes hello, and then we're done. And it says go back to where you remembered you were supposed to pick up next, which is here. Okay, so it says pick up next. Then it goes on to the next statement. Here, greet. So it's going to run this function again. Remember where to come back to, which is right here. Jump up to here, and then make es this time be what lang means. And so now lang is es, so this is true. We run that code, we come out, and we print out hola, and then we go back to where we remembered before. Then we continue on. Come to this code. Okay, so now we're in this code. It's time to run greet again. So we jump up to here, and then this time FR is lang, and so it runs here. That's false. This is true, so it prints that out, prints out bonjour. Then it comes and it remembers, oh, forgot to remember where to come back to, continues on. Okay, so you see the whole pattern there. A lot of different pretty colors there, but you get the idea that it gets run a couple of times, and lang is the alias for whatever the first parameter happens to be. And that's the best way to think about it. Whatever the first parameter is, I will use lang within here. I'll use lang to refer to the first parameter. You might name this thing, don't do this, but you could name it P1, P1, P1. So parameter 1. No, Python wouldn't care, but it's really just the first parameter. Lang itself is not really a variable in that there is no piece of memory that lang belongs in. It really sort of is an alias of something else. Okay? Okay. Now, when we're looking at like the float statement or the input statement, we see things like, input, parenthesis, blah, 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 parenthesis equals x, right? And so we're going to assign something. The question is, what is this residual value that comes back? And within the function, we as the writer of the function get to determine what that residual value is by the return statement. So basically, even though this is really a trivial function, has no parameters, the return statement does two things. One, it stops the function, and it jumps to that next line, right? But two, it also determines the residual value. So by saying return, if we come in here, and so we do this, then we're in the middle of this print statement, so it sort of pauses here, and then it runs this code, and then the return says, oh, this little bit that was the function, send that back right there. So that means that this is really print hello Glenn, which prints out hello Glenn. And then it goes on to the next line, it runs greet again, comes in here, and so now hello becomes this residual value. Now it's not very clever, but you get the idea. This residual value, it's like hello Sally, so it prints out hello Sally. So here's a little better example of this where we're using both arguments and a return value. So again, this just remembers it. We're going to say greet and en, so en is lang. Greet is going to run, and then runs this. Here now we've returned hello. So this hello becomes this. So hello is the residual value of the function evaluation, and so out comes hello Glenn. So now we do this, greet es, so we're going to call this code, and es is going to come in as lang, and in this case it's going to run this and return hola. So hola is going to then become, this replaces, and that says hola Sally. And so now we're going to do it again. Greet fr, greet comes up here. We're passing in fr as the language, false, true, and then return. Return doesn't come out here. Return is done. That's it. You're done at that point. And you also specified the residual value of this little bit, and that's bonjour Michael. By the way, Glenn, Sally, and Michael are real people. I always just use names of real people that are actual people I know. Okay, so now what we're going to do is going to take a look again at that max function, but we're going to understand how the return works. This is really more about the return. So if we take a look at max, right, this is so we're going to evaluate the right-hand side of this so we have something to send into big. So max hello world says take this parameter and send it into max. Here's the max function, right? And so hello world comes into max as some parameter. We don't know what it's named inside max. We really don't care. But it's going to do something, read some stuff, check to see if it's a string or something, and then it's going to loop through a bunch of stuff and figure out what the largest thing is and figure this out, read through, pick the W as the largest one, and then it's going to execute a return statement because it has to pass back the W to us. right? So to communicate out of the function back to the real world, here's our real world here, it says return W. Now it's probably a variable, but you get the idea. It has to run a return statement, and that's the end of execution. It doesn't continue. It doesn't even run a single statement after return. But then it sends back to us to replace in this function, in that original statement, the W then becomes the residual value. And then the W is what goes into big. Now, after a while, you won't need to look at all of this syntax in such detail. I just want you to be able to know every single character and what they mean and slow this down into slow motion, because after a while, you'll just type this stuff and you won't even think about it. But you need to be able to slow it down to sort of slow motion if you need to. Okay, so you can have more than one parameter, as you might well expect. This says I want 2 parameters. Again, the name of these things inside here hardly matters. Just that's the first parameter, that's the second parameter. In a call, we pass in 3 and 5. So that is easy. The number and order of the parameters is the same in the function invocation as it is in the function definition. And we just add these 2 numbers together, make it local variable, and then return it. So 8 becomes what comes back and gets stuck into X. So more than one parameter, more than one argument, no problem. The names of the parameters inside the functions, no big deal. So some functions do not return values. We call them non-fruitful functions. And if they return values, then we call them fruitful functions. So in summary, this was a pretty quick introduction to functions. Like I said, I don't really expect you to build a bunch of functions, but I want you to understand them. And so when the time comes and you're thinking to yourself, oh, wow, it's time to build a function, you'll know how to build them and you'll know how to use them.